Welcome to the CITRIS lunch lecture series, and it's actually a special day today because it is National Administrative Assistant Day. So if you have an administrative assistant, if you work with one, wish them a happy day. And in particular, I think it's a perfect opportunity to wish Yvette Subramanian a huge thanks from all of us for all of her work on 1,000 different fronts to make this series happen around here. Yvette? We love you. And we also love Kosorov in there in the control booth. It makes all the AV work smoothly. So my name is Ken Goldberg. I'm a professor upstairs. I work in the area of robotics, and I've worked in this field for about 20 years. And one of the colleagues who's been extremely energetic, who's done a lot of work in a variety of different areas, is here with us today. Before I introduce him, what I'd like to do is welcome the web viewers out there and mention a couple things that are other events that are happening next week. We're not slacking off as the semester is over. In fact, just the opposite. There's going to be a whole host of major events next week during Reading Week. In particular, on the 3rd of May, on Tuesday, we have Anh Lim Go, who's the Chief Technology Officer at SGI. Will be here at noon on Tuesday, not Wednesday. And then on the 4th, we have Bill Joy, co-founder of Sun Microsystems, who will be here in this auditorium on the 4th at 7 p.m. And then that's for a Regents lecture. And then on the 5th, why did I say Tuesday, May 5th? I'm going to say that's Thursday, May 5th. James Sporer from IBM is going to be here at 1:15. And then there's a major event on Thursday, which is going to be held all day here. Actually, it's a science lecture series on computational science and engineering, and it starts at 12:15 with a lecture by Jose Carmina from here at Berkeley. And there'll be a number of lectures related to computational science. So we have that to look forward to, and without any further ado, I'm going to introduce Rich Mahoney. He did his undergraduate work at Drexel in Philadelphia, my old stomping ground, and then went on to Cambridge, where he had a Fulbright fellowship at the University of Cambridge. He has done work in a variety of different startups related to robotics, and particularly medical robotics, and he's also been involved in academia and research labs, and he then has become the director of the robotics program at SRI. And SRI is a major research institution here in the Bay Area. They have made contributions in a variety of areas. And so in their robotics group is well known for making contributions over the last really 40 or 50 years in this area. So what's very exciting is that Rich is rather going to look backward, he's going to look forward. He's going to tell us about the next 20 years, what's going to happen from SRI and around the world in the field of robotics. So welcome, Rich Mahoney.
Thank you, Ken. Good afternoon, everyone. Thanks very much for having me here today. I've been looking forward to the opportunity for this talk for a long time. One of the reasons is that for me, I'm definitely going to be looking forward, and a title like The Future of Robotics is really pretty ominous, and as I was preparing this, I was trying to figure out how I got in a position to even be asked to give a talk like this. But part of my talk will also be about where I'm coming from, so I'll touch a little bit on my experiences and perspectives, and then sort of at the end make some wrap it up in terms of the direction I think things are going. Part of my role at SRI is to strategically manage our robotics activities. So the nature of our business is to operate 5 to 10 years ahead. So I'll be sharing with you some of the things that we're working on now, and that will definitely be pointing to the future, and will also lead into some of my final comments. So just a quick overview of the things I'll talk about, just to give you some of my background. I like to be in the know on what's going on in robotics. I've been doing robotics for 23 years. I'm not somebody that was in a robotics club growing up. I love science fiction and was interested in technology, and I kind of stumbled into robotics and somehow found really interesting positions for 23 years, and now I've come to really be an advocate for the potential for robotics. And part of that is knowing other people doing robotics and trying to understand what are the factors that drive commercialization and drive us towards this expectation of what everybody wants robotics to ultimately be. I'll talk a little bit about things that I think are going on with robotics companies, highlight what's going on at SRI, and then I'll wrap up with something I call the good robot. So quickly on my background, Ken touched on my education, and one of the things I'd like to highlight is at various stages the kinds of things I was doing. So I did a mechanical engineering degree. My PhD is in engineering. It was a speech vision robotics group at Cambridge, but it was very much applied work looking at vocational applications of rehabilitation robotics. And I spent a lot of time in manufacturing facilities and doing surveys of industry, and what I was looking for at the time was jobs that could be where a robot could be introduced and create opportunities for people with physical disabilities to be able to become employed. And one of the things we discovered is that visual inspection was an ideal kind of application. But as part of that work, I was doing research. I got a lot of exposure to the real world manufacturing environment. Then I sort of went into this R&D phase where I was in a traditional university-based research center. We were funded by the Department of Education, and we were looking at broader applications of robotics for rehabilitation and assistive kinds of solutions. At that time, I actually really became a little bit frustrated with the work that I was doing from the point of view that the product I was working on were really research projects and publications. They were the sort of traditional outcomes of working in that university setting, and the goal of the work was to publish and look for the next opportunity to get funded. And I was really interested in seeing things get into the market. So I had an opportunity to leave the university environment and begin working in early stage companies trying to see the development of products. And I had along the way the opportunity to introduce 2 products. One of them is not on the market, but I got it through the whole FDA process and got it on the market and learned a lot. And then a robotic stroke therapy aid in my next position at Motorica as general manager. And in each step, I was sort of getting a higher levels of responsibility. And today, working at SRI, I really like this environment. SRI is a nonprofit. It used to be a center of Stanford University, and it does early stage technology development, but places a high value on commercialization. So I really get to sit between basic research and commercialization. So one of the things, I'll just give some observations and perspectives on the general state of robotics. I do believe that we are at the dawn of a service robotics industry, where I like the analogy that Steve Cousins, who's the CEO of Willow Garage, uses, where the industrial robotics are robots in a cage, and service robots are robots outside the cage. And really the focus there is on interaction with people, augmenting people, and creating opportunities that go beyond what pick and place tasks and other industrial tasks, but really helping and aiding people to go further. There's definitely a lot of things happening in military applications. I'm not going to touch on that as much today, but it's definitely a driving force. There's also it's understood that governments around the world are really investing in robotics, and it's often been referred to as their mission to put a man on the moon. Countries are looking at robotics as a solution to all kinds of ills, including in places like Japan, being able to take care of the growing population of elderly there. The other thing that's happening is there are lots of technologies that are becoming very commonplace and available to the everyday developer. So robotics used to require very expensive equipment and technology, sensors, motors, a lot of skill and training to be able to work in the field. And today, robotics is very accessible from the technology point of view. Another thing I like to point out is over the last 30 years, especially since I've been involved in robotics, universities have been educating roboticists like crazy. There are, don't just think about the top tier universities that are where you can get a robotics degree, but lots of secondary places all over the world. There are a lot of people that know how to do robotics today. Also, I jumped over this one bullet. There is definitely a growing demand for low-cost hardware. There's funding that we have in our lab that's from DARPA, specifically targeted at creating availability of low-cost hardware in the market. Following from the comment about people coming out of universities, there's also an explosion of robotics in education. And this is, people know about the first competitions, but robotics is actually being, it's one of the leading technologies or leading applications that is being highlighted as helping to educate people in science, engineering, and math. So people see it as an excellent technology and an excellent approach for getting people excited about going into those fields. And then finally, there's all kinds of market forces that are going on, healthcare costs, the need for elder care, U.S. competitiveness, there's investments starting to occur. It's actually, it's easily the most exciting time that I've seen in robotics since I've been doing it. So along those lines, one of the things that's happening throughout the country is that there are these clusters of robotics companies that are forming that are based on a critical mass of either technology or companies that exist in those areas. So the first one, and probably still the leading one, is in Boston. There's also one in Pittsburgh and Detroit, a few other places around the country. And although there was a lot of really great work going on in Silicon Valley, Bay Area, there really was no cluster, no community of companies interacting. And so we at SRI put a request out just over a year ago to see if people would be interested in coming and meeting with us and seeing if there was any value in forming a cluster. And it was an easy thing to do. There was a ton of interest, and it was an obvious thing to do. And since that time, we've been meeting and have really established a specific mission of raising awareness of robotics in this area, the Bay Area, greater Silicon Valley area, attracting and retaining thought leaders and resources related to robotics, and to grow the Silicon Valley robotics industry, creating opportunities for new and existing companies, and creating access to funding and networking. There's an active working group, and we're in the process of forming an industry council that will act as a leader for that organization and giving it direction. And if you're interested, svrobotics.org is the website that we have set up. It's still very much grassroots, but it's definitely established now. Here's a list of the companies that attended the first meeting last year. A lot of these you know. So another thing that's evolved from that is the Silicon Valley Robotics Cluster. It has emerged as the leading organization for National Robotics Week activities in the Bay Area. So the National Robotics Week was mandated by Congress last year, and we had the second week, the second event, second week of April, and there were a number of activities. There was basically an event a day happening all over the Bay Area, and I attended we had a booth at a block party at Stanford that was really exceptional. There were hundreds and hundreds of families, robot clubs that came together. It's one of the few places that I've seen where people working in this kind of industry had the opportunity to interface with the general public and vice versa. And I thought it was a really powerful environment. Another activity that took place that week was hosted by Adept, and they had invited their Congressman Jerry McNerney, who represents the Pleasanton area, to just come and meet with a roundtable of executives representing robotics companies. And it was a really interesting meeting. I fully expected it to be about how do we get more funding, how are you going to raise the profile of robotics so we can sell more robots. And really interestingly, the concerns that were raised were around liability. So we're going to put robots out there, and robots, although they can do a lot of great things, there's also greater concerns around how they're controlled and the kinds of things that they can do. And there's misperceptions about those things that are causing liability concerns that are keeping people from bringing products to the market. The same thing, regulatory challenges. So for medical robotics and all kinds of applications, how do you, the FDA is sort of still crafting its perspectives on how to handle certain types of medical devices. And interesting, immigration emerged as a problem, that a lot of these companies are attracting staff from overseas with really strong credentials, and they're being wrapped up in all of the kinds of things that are going on around immigration in our country today, and it's creating barriers to attracting and keeping good staff. For me, one of the biggest takeaway was and this was in interacting with Congressman McNerney, is that there really is not a central policy focus at the national level for robotics. There's definitely an understanding of what we've done in this country and the potential of robotics as a technology. But most of the focus is on raising funds and having funds be available, which is absolutely essential to the technology succeeding. But at the same time, there are many things that you can do when there's a vision of how robotics can serve the country in terms of lowering healthcare costs or creating more job opportunities by redirecting existing resources in a way that are in alignment with those with that vision. So I think it's a challenge right now, and I'm not sure of the answer. There's definitely organization going on within the U.S. in different areas, and there's communication with Congress around robotics, but it's not clear to me how that policy will get articulated. And just out of interest, there are 2 congressional caucuses that exist now that serve the robotics industry. So one specifically on robotics and another one on unmanned systems. And I personally think at some point they're going to have to converge because they're looking at many of the same kind of issues. So I'll shift a little bit and talk more specifically about some of my views of starting robotics companies and the status of robotics companies. And there's 2 really great success stories that are often put out there around the robotics industry. So IRobot and Intuitive Surgical. So IRobot was founded in 1990, and I checked this morning, its market cap was $1.0 billion. So it reached the $1 billion mark, which is pretty significant. But its stock, I remember in 1999 2008, 2009, when the stock market went down, that it was selling around $7 a share, and this morning it was trading at about $38 a share, so over a 500% increase. And their products are really solid and doing well. The 2 cornerstone products are the Roomba vacuum cleaner, which has now sold over 5 million units and established that market, and the PackBot bomb defeat robot used by the military, and they've sold more than 2,000 of those. And the founders of that company, 2 of them have left. Rodney Brooks has set up a new company called Heartland Robotics, and they have $27 million worth of investment to look at new robotics for manufacturing applications. And Helen Greiner has started a company called Sci-Fi Works looking at unmanned air vehicle applications. And she also has some institutional and government investment. The one thing to say about this, and the reason for the question mark, is that the company was founded in 1990, and it didn't go public until 2005. So there's not many investors that will look at a company, if that was your business plan, that they would put money in. Most companies are looking for, or most investors are looking for a much quicker turnaround than what you're seeing there. at the end of the day, this is very successful, but it's also a warning sign for people that are looking to put money into robotics companies. Intuitive Surgical is another story. The first demonstration of surgical robotics that led to the founding of Intuitive Surgical took place at SRI in the late 80s and early 90s. The company itself was founded in 1995, became public in 2000, and I looked it up. Its share price on April 26, 2001 was $13.22. So I know exactly what I would do if I had a time machine. But the main product is the surgical robot. They have over 1,800 sold now. There are tens of thousands of surgeries done with the device. 85% of all prostatectomies in the U.S. are done with the daVinci system, and there's at least one spin-off. Hansen Medical, one of the founders of Intuitive, has started his own company. But again, I know from being at SRI that the history here is really difficult. This company was not thinking it was going to be successful in that first 10 years. And they spent a lot of time in the market trying to find what the exact revenue model was, what the exact type of surgery, what was the right application where they could get regulatory approval and reimbursement to have a successful company. So both companies took more than 10 years to solidify. And to me, one of the key barriers to successful companies today has nothing to do with technology. It has to do with the lack of experienced business professionals starting robotics companies. I think I'll talk about this later. I think the challenges for starting a robotics company are great. And I think these companies took 10 years, and the reason they exist and others don't is because the business leadership in those companies figured out how to survive. They figured out how to raise enough money. Both of those companies went through periods where they let go a significant number of staff, where they had to reset their business plans multiple times, and that really takes business leadership and experience to know how to do that. So some of the reasons I think that's true, and so I've been in this situation of starting up a robotics company, and there really is a greater risk in the hardware development. And so the advantage of robotics is this flexible technology that can do these amazing things, but at the same time, you're often avoiding a technology push. What is the exact form of that flexible technology? So if you can only invest one time in building your prototype, and you've got an infinite number of approaches to building it, how do you decide which one to build? It's a real problem. And then the hardware support for these machines, the quality assurance and the tech support is generally higher than what you would find in other businesses. And then you also have the challenge of a sustainable market-oriented business model. Should it be a capital sale model or a service model? And again, there's this gap in experienced management teams who have the knowledge of robotics and who are also ready to address the market side. Having said that, there is some activity that's happening, and I'm highlighting a lot of things that are going on in our area now. Bosch is based in the Bay Area. Their venture group is actively investing in robotics companies. They've invested in Athon, a company out of Pittsburgh that does hospital tugs, and a few other companies, and they're actively looking for companies to invest in. Adept is interesting in that they are the oldest robotics company in the U.S. right now, primarily doing industrial robotics, and they are now repositioning themselves to address the service robotics market. And there are a number of up-and-coming Bay Area companies, Berkeley Bionics here in Berkeley, Restoration Robotics, working on hair restoring robotics, Nito, a new vacuum cleaner, Liquid Robotics, doing ocean monitoring, and these companies are all emerging and successful in their own right today. So one of the interesting trends that I wanted to share with you, you're probably aware of the emergence of telepresence robots, and this is something that's happened really quickly, and it has to do with the availability, readily available mobile bases and other technology that it was very easy for companies to be able to pull them together into new platforms. So one of the first companies to do this was over on the far right in the middle. InTouch Health created a device that allowed doctors to dial in and do their hospital rounds visiting patients in a hospital setting without having to travel to the hospital. And that company has been established for, I don't know the exact number of years, but a good 5 years now, and I know their revenues are in the tens of millions of dollars. They're pretty secure. Anybots up here in the corner, there's an excerpt from a video where they sent their platform from God bless you, they sent the platform from their offices down Castro Street in Mountain View into a coffee shop to order a bun or something like that. There's another robot here down in the right-hand corner, Vigo, based in Boston area, I believe, and they sold a system to a school district for a child with an immune deficiency, and he used it to go to class every day, and there's a really great video showing him, and it's one of the first videos I've seen where you know there's something there. The student was really engaged. The other students were interacting with him in a school-like setting, and it was really compelling. This robot is Willow Garage's version, TechSci, and this is iRobot's version that's not on the market yet, but they showed. And so what's happening here is there's a huge tech push going on. None of these systems have a market assigned to them yet. And they're all running around. The companies that can do it are quickly putting their platform together because they're waiting to see what's going to happen. So there's some compelling examples that are occurring, but we're waiting to see what is that first business model that helps this take off. And I personally think it will happen. I don't know what it will be. I like the idea of premium presence. So I want to be able to log in, and I'm a Phillies fan. I want to be able to drive around the Phillies stadium after the game is over and just be in the ballpark. Or I can picture these getting dropped off at a wedding and relatives that can't make it being able to be out on the dance floor and interacting with people. Or maybe there's some events like the Oscars or something like that that people will be able to dial into and experience in a different way. I think it's worth highlighting, and I do think it's the next kind of application that will emerge. So I'll quickly go through some of the things we're doing at SRI. The focus areas I'm going to touch on today, we're doing a lot of other things, but the things that are pointing to the future are this concept of unmanned manipulation. We have a number of projects introducing new component technologies that I brand under the moniker of redefining the design space for robotics, kind of moving away from our electromechanical heritage. And then I'll just touch on briefly on a couple other areas. So as I mentioned, the first demonstration of surgical robots took place at SRI in the late 80s, and this system on the upper left-hand corner is called the M4, and it was the first platform to demonstrate telesurgery. We still actually have that platform in our lab, and we're trying to decide what to do with it. It's in pretty good shape, and we might donate it to the Computer History Museum or something like that. And in that system, the exact parallel of that system are the two components there. The daVinci product is the user interface and the robot itself. And both of those have significant IP attached to them that allow them to be successful in the market. So while Intuitive was off commercializing the daVinci system, we continued to work on our own demonstrations and other problems around telemanipulation. I'm just going to flip. I'll just touch on this briefly, but this is a system we call the M7. And it is a dexterous telemanipulation device. The interface is very similar to what is used to operate the daVinci system. And this is a completely unplanned task. We just threw a bunch of things in a bag and closed the bag and put it in front of the system, and the operator on the other end just began opening it and looking through it. A lot of people will challenge whether this is a robot, but there is a wired connection between our input and the device itself. So what you're seeing here is pure robotic movement, but it's driven by a remote user input. And then one of the things that so our focus here is on dexterous telemanipulation. And initially we were looking at broader applications, surgical, medical types of applications, but really what we've discovered is we have a very strong platform for doing lots of different types of dexterous tasks. yet. So what we've been working on recently, and I'm really excited about this, is a device we call the Torus. And we received funding from the Department of Homeland Security from a group that addresses vehicle-borne IED defeat to create a new device that would allow bomb techs to be able to explore and defuse a robot without and go beyond what's possible in the existing robots that are used by bomb squads. So this is a early prototype of the system, and we'll be demonstrating this through the summer. But what we're showing here is the dexterous telemanipulation ability that exists in the daVinci system is available in this system, and we had a lot of constraints because of this application for a vehicle-borne device. We needed to be able to reach inside of a trunk or inside of a window, so this system folds up into something the size of a shoebox and has pretty limited, is 15 pounds and is intended to be picked up and held out to whatever the task is. But because of that, it's very modular, and we see this as beginning to look towards many other types of tasks that can be done with this kind of technology. So moving to the next type of work that we do, this concept of new component technologies. SRI introduced electroactive polymers, EPAM, to the world again in the early 1990s. So this technology is polymer based and allows you to both create an actuator if you put current through the system, but you can also collect energy when you do work on the system. So we have applications both as a motor and as energy or for power capture or different applications. So here's an example of a buoy that we created that was outfitted with artificial muscle, and we were able to generate power from the shaking of the buoy from the waves. So we put out a new company called Artificial Muscle in 2006. That company has been working diligently to get its first products on the market, and there was a lot of issues around just improving the manufacturing process, qualifying the manufacturing process, again, finding what is that first application that where you can have sales. And so we're now focusing on, we have the first consumer product that was issued this year. It's the Mophie Pulse, and it uses also a capability of the technology for high bandwidth tactile displays. So this is it's basically a tactile display that allows you to put many different kinds of feelings across it related to whatever the task is you're doing with the device. Another application of artificial muscle, which is also really interesting, is the artificial muscle incorporated addresses all markets except implantable uses of the technology. And we've been working over the last 2 years on a project that allows us to, the application is to reanimate an eyelid for nominally for a soldier that's lost an eyelid in a blast in the field. So we've actually got this project all the way to the point where we have a demonstration system, and we've done demonstrations of it with physicians at University of California at Davis, and not in live patients, just in cadavers, and we'll be publishing those results later. But we think that there's many kinds of applications for this that because of its low footprint and ease of manufacturing. Another technology we're working on is something called ElectroAdhesion. So this is basically the physical property that when you rub a balloon on your hair, and you can get electrostatic forces to stick that balloon to the wall. So we have an approach that allows us to switch the electrostatic forces on and off under our control. And we're able to use that for lots of different kinds of applications. Another element of it is the compliance and flexibility in the materials that we apply it in. So in this case, we're hanging a 75-pound weight off of a wood substrate using just 1 millimeter thick mylar. And we have a couple of different cool applications for this. So here is, again, the Department of Homeland Security funded us to create pads that would be able to hold countercharges on the sides of vehicles. So up until now, the bomb squads would use duct tape, and they would lean chairs, and they had really no good technique for doing it. And here we're showing lots of different examples of just being able to put something on the wall, turn it on, and have it stick. And here's just an example of a bomb squad in Sacramento using a robot to place the countercharge remotely using these pads. So another interesting application is we realized that this could be really valuable in material handling and gripping. So imagine being able to pick up objects without applying any forces to those objects. You could just wrap something around it, switch on the electroadhesion, have adherence, and then be able to pick up the objects. I'll show you an example of that. So here's a simple tendon gripper. There's no forces being applied. It's not on. We're using the M7. We reach over, turn on the electroadhesion, and we're able to pick up that can just by wrapping the gripper around. And what's interesting is that we're really fundamentally changing the grasping requirements. It's a brand new technique. We're in the process of setting up a company that will address industrial material handling. We think that we can put a big dent in the use of vacuum grippers and also overcome lots of challenges with those in terms of energy consumption and noise and the cost of those systems. So, and the other thing about electroadhesion is it works on glass and wood and paper and concrete and brick. So you're able to use it on lots of different kinds of applications on lots of different kinds of materials. So while I'm here, I'll show you our next application is wall climbing robots. So here's a simple tank robot that we've been developing with some customers in Japan, and this is for visual inspection of concrete bridges and overpasses, supporting a company that does that job in Japan. But this is just a mule. It's a basic, I'm looking at this as a new type of mobile robot that can just climb walls. It will hold, this particular one will hold about 200 grams in addition to its own mass. It's moving kind of slow now. It can move a little bit quicker than this, but it's not really designed to go quickly. And again, it works in all kinds of materials, glass, wood, concrete.
What's the adhesion part?
I'm sorry?
How is it here?
The electroadhesion, so electrostatic forces. Yes. So one other thing that's I want to note is that we have some really good work going on in developing a new micromanipulation platform. I'm not going to show that today, but we're planning on announcing that at IROS. And we see it as a solution that will allow for high throughput manufacturing at the micro scale, such that it will allow outputs at the macro scale. So it's, I'll just tease you with that information, and we'll have a paper at IROS and demonstrating that at IROS as well. Another area of work that we're doing is human behavior assessment, and we're looking at using vision information, speech information, vital signs to try to understand human behavior. So for instance, we are using speech to see if we can assess the depression state of soldiers, to see if we can actually identify soldiers at risk for suicide, and we are actually having success in that area. And I see that as another kind of technology development that will impinge on robotics as we go forward. So, okay, so I'm going to wrap up now, and I'm not going to talk about specific platforms and the kinds of robots that I think are going to be out there in the future, but I'd like to give some insights based on my experience and how I think robots are going to evolve, and I think relatively quickly to bring value to us. So one of the things is, first off, robots are here, and people keep waiting for them, but they're here. And I see home printers, powered wheelchairs, the robot vacuum cleaners, toys, military robots. There are a lot of robot solutions that are successful. They're not going away, and there's a lot of critical mass around new types of robots. I think there's an expectation that the robot market is going to grow, and everything seems to be happening that's going to cause that to occur. And I think the conditions are here. The fuel, the low-cost technologies, the computing resources are here. The oxygen is starting to flow, the money coming from investors and companies wanting to see access the value of robotics. And I really think the energy, the heat will come from people. And I see this as one of the gaps right now is just the people, as I was saying before, that are getting in front of these companies and not just pushing technology, but are addressing markets. But what is this ultimate driver of value for robots? And I'll point to it from a couple examples. So this is a project called TraumaPod, and it's a follow-on to the daVinci work at SRI. And essentially, where the daVinci's here, the project was to automate the entire surgical suite. So I won't show you too much on this, but we basically took all people out of the surgical suite and had the surgeon completely supported by automation. And one of the keys to that was the user interface, and that was a big deal in the development. But one of the outcomes that wasn't necessarily thought about when the project was being done was this ability to now document the entire surgical process. So what you could do at the end of a surgery is you could press a button and ask for an inventory and immediately have validated that all of the tools, utensils, sponges, everything was accounted for, and none of them were inside the patient. So that is, it seems like an insignificant thing, but it's a big deal that can be tied directly to some business driver. And it's, from my point of view, there's 1,800 surgical robots that daVinci has on the market. It's just a matter of time before those are networked and they're providing that kind of data into the medical community. So this is another robot. This is actually the robot I worked on in my position before coming to SRI, and this was a device for recovery of arm function following a stroke. So rehabilitation is required. There's lots of additional recovery that people can get from their arms if they are able to access the rehabilitation. There's lots of drivers that limit the amount of arm therapy that people are able to get. So a device like this, where you can create engaged exercises focused on the arm, has an opportunity to increase the outcomes for people recovering from strokes. And there's lots of clinical evidence, and we now, when I left, there were 50 systems in the field. I think there are over 80 now. So one important thing about this is that the therapist is making the decision. So here's a set of the exercises that a therapist does, but that the therapist will choose for the patient to do. So all the robot is doing is the routine movements with the patient once the therapist decides what that engagement will be. So a key thing there is that all of that information is now documented and collected by the robot. And typically, a therapist will spend an hour doing therapy with a patient. They will do 30 or 40 arm movements. This system will do between 400 and 600 arm movements in the same amount of time. And that therapist will usually spend 45 minutes documenting that therapy session, writing up a report that will then go into the reimbursement process. And normally 15% of those are rejected because the reporting wasn't done correctly. With a robot in the loop, you now capture all that information, you get better outcomes for the patient. The therapist takes 1 minute to do the report because they press a button and the robot creates it, and it creates it in a format that is perfectly aligned with the reimbursement. So you're increasing the revenue for the clinic and reducing their overhead. It's the kind of thing that drives the success of robots, but you're not going to find those solutions unless you're actually you're facing the market. So my message and the messages and the things that have emerged for me as the drivers of robotics going forward is I really view robots as the interface between the physical world and the information world. I came to SRI and I said, hi, my name is Rich Mahoney. It's all about the data. And they were all looking at me like I was crazy, but I really think that the value of robotics is in what we do with that data and how we use it to move the technology forward. So in the case of the examples I gave you, what we're really talking about is quality. And so a robot gives you, once you've introduced a robot into the environment, and especially if that robot is capturing activity that a human is doing, you're now in a position to measure quality and actually to some degree to guarantee that quality. And I think quality is an underappreciated outcome of introducing a robot into these service applications. And so this to me is my big message. Whereas the internet democratizes our access to information, robotics democratizes our access to equal quality physical experiences, where robots understand what the best quality is and can deliver that. We're now, if you think about it in a healthcare application, we talk about access to healthcare. Well, it should be access to equal quality healthcare. People run to doctors because they're better than one other doctor. They want to go to a hospital because it's better than another hospital. That robotics has the ability to level the field in terms of the quality that you're able to deliver. And so if you look at that quality, that's leading to better performance, leading to standards, it creates efficiencies. And so what I discovered in my time in leading robotics companies is that those are really business drivers that you can use to validate that device and get sales and build the acceptance of that device. And then you also can create service opportunities off of that. So you're not talking about the robot now as a piece of hardware, a capital equipment, which is a much more difficult sale. You can actually introduce it under service models that now start to look like cell phones and other kinds of computing applications. So at the end, we also have a chance for discovery when we start to aggregate this information across many platforms. And so I'm going to end with this idea of the good robot, and it's one of the things that I've taken upon myself after spending this much time in the field. Is I love science fiction movies, and I love the movies where the robots take over the world and we come back and save ourselves. But it's kind of a tired routine for entertainment. I actually think that the way robots will evolve, it will end up being better than we even expect it to be. I know when I was talking to therapists, they would say, "Oh, there's that robot, you're going to replace me." And my answer was, well, first off, you're not treating anybody in the hills of South Dakota. You're not treating anyone in rural India. And you're also only doing 40 movements per session when people need 500 movements per session. But also, if I'm capturing your best performance and helping you deliver that, at the end of the day, I'm not replacing you. I'm immortalizing you. I'm taking the best performance of our best people and making it available to everybody. So again, you're not replacing, but you're augmenting and immortalizing. Going back to this idea of you're democratizing our physical experience, enables access to equal quality services. And at the end, those services can be delivered anywhere and controlled. And those high-end services will ultimately become commoditized, and it will change the way that we're interacting with them. So this is my message about robotics and the future. Is I think robotics will evolve not necessarily around hardware. We're already addressing these low-cost hardware. It's going to evolve around the business models of how we use the data that we're collecting for these different applications and how that evolves into delivering value in the form of quality and services to the general public. So that's the end of my talk. I appreciate your attention, and if you have any questions or anything you'd like to add, I'm all yours. Thank you.
Yeah, hi, Igor Poprotny, UC Berkeley. That was very interesting what you said about sort of using the robots to capture the best performance of the physicians in an operating setting. But I mean, my question is, do you really need robots to do that? I mean, are there ways we could use technology to capture that anyway in an operating setting? Because I think that's exactly the case, like the inventory which you mentioned, where you want to make sure that nothing is really left in the patient.
So the answer is absolutely yes, and that's already happening with other technologies. So there's many kinds of uses of computers that do that. And so there is the corollary to this is that this is in applications where robotics add value. In the case of surgery, there's lots of benefits to using a surgical robot. It enables minimally invasive surgical techniques that a lot more surgeons can access. So that basic benefit then carries through with the kinds of things I'm talking about.
Yeah, but I think also maybe in the same way, sort of a hybrid technology, you do actually capture, say, the strokes or the best skills of the surgeons, right?
Right.
And in a way try to...
Yeah,
to use the surgeon as an actuator in a sense, right?
That's right. And so the trap that I see there is that often people will say, I'm going to capture this, and they'll just focus on what they want to focus on. And my experience is that you let the data, so being immersed in the market, so I was able to learn how the data, the reports from the robot tied in with the business drivers, and that was of higher value to me than trying to automate what the therapist was doing in terms of getting acceptance. I know when I talk to people at Intuitive Surgical, why aren't you using the data for this? Why aren't you doing these things? You ask them all these questions, and they're facing the day-to-day realities of this surgical robot in a highly regulated environment, and they're making decisions that allow their company to survive, not that automate something that seems like they should be able to do it, if you understand the view I'm giving.
Great, thank you.
Rich, great talk, and I'm really interested in the range of devices and things that you guys are producing, and I'm curious, to what degree are you looking into robot learning? Because it seems to be having a lot of impact in a lot of labs. Right. How are you using it?
So we're not using it right now, but we are interacting with the Artificial Intelligence Center at SRI and beginning to look at how to structure learning in these kinds of in these kinds of formats of telemanipulation. So yeah, so it's not. For right now, we're mainly focused on human in the loop and getting that dexterous performance and applications where you need that human in the loop to have value. Okay. And the only learning we do is something I call like an accounting stage, and it's referring again to the reports. It's what's the data that you're getting off the system that you never had before, movement times, movement speeds, right. All these kinds of things that suddenly give you lots of insight that we never had before. And then he'll do the down select based on a hardware demonstration instead of just a design. Yeah, thanks for that.